Hello and welcome to the All Things ITSM Global Podcast. We're here in Las Vegas at Knowledge 16. We're here with Ken Gonzalez.
Hi, Carlos.
Charlie Betts.
Hey, Carlos.
And our special guest, David Laing from IDC. Welcome, David.
Thank you, Carlos. We're glad to be here.
So one of the things we've been talking about and seeing over the course of the conference is around digital transformation in IT organizations. Along with this, there comes the desire to have organizations with higher levels of maturity, have the right tool sets and be using them properly. One of the areas I found that you were involved in was industrial control systems and embedded systems.
That's correct. Embedded computing systems, intelligent gateways sometimes act as a good isolation, but a place to add context to data from these control systems. And we have to remember that a lot of these control systems were designed back in the day where they were just put together with machine code. And these systems, the engineers never even considered that somebody would, actually try to bit bash and get in there and do something malicious. But as we find out these days, as they try to connect these systems, people are in fact trying to do that exact same thing.
It seems to me, having done some embedded development myself, that there's a level of rigor that's required that from a commercial application standpoint you don't necessarily find. Are there things like that that you can see that would aid a traditional IT organization in raising their level of maturity and ability to deliver?
Well, there is going to be a convergence in between the two worlds. I mean, there has to be. And the question is that there are some very distinct things that are different about embedded computing that's much different than your traditional IT environments. IT environments will talk about pushing a patch every few days if you have to, whereas an embedded environment is extremely stable. And in fact, that's one thing that they look for, is that the OS is not going to change. And it can't, because if these things have gone through a lot of certification. And I imagine the same is true in medical, but and any time you change anything, you might have to go back and get TUV and even noise and all kinds of certifications. And so you just don't change things that quickly. I mean, it has to be tested out, it has to be stable, and then you can't change it. And IT doesn't work that way. You talk about DevOps or something like that, and how you're measuring things and you're changing the things, very quickly to rapidly develop a program. That's quite different than an embedded environment.
Yeah, very different cultures, very different traditions. In fact, I think that there's been a long history of operational technology groups telling IT, just keep your hands off my stuff. It's very different conversations. But as you say, as these things all become interconnected, how do you actually bridge these worlds?
Well, that's I think is the key to success, because these systems contain a lot of very valuable data that can be used to put, as long as it's got the right context. You cannot take a flood of data from a particular sensor or industrial control system and just send it to the cloud. That makes no sense, because you've got to put context, and that's where sometimes these intelligent gateways fit in. And they're not always located in data centers. They could be co-located with the equipment. And what they do is they put the necessary context to the thing, package the data together, which often comes from completely different data buses and structures, and put it into context about what was going on in that particular day or in that particular environment. And then something knowledgeable can go to the cloud and be aggregated to provide all kinds of information to the end user.
Yeah, it's funny you mentioned the manufacturer, because I was working with a client and they were working on the configuration management side, and they actually brought up, we have these tolls. They were manufactured, so as things go through the production line and come out the other end, there's sort of a turnstile. And they're like, the turnstile has electronics on it, and we want to put the turnstile in the configuration management system. And you start thinking about this, these are production line pieces that are now going to be managed in that same operation. But like you said, the security aspect of it, now it's there. Nobody was planning on a turnstile at the end of a production line to be part of this. So that just seems like it opens up the whole dynamic of what we do day in, day out to all sorts of issues, I would think, and disciplines that we may not have.
Yeah, that's interesting, and actually, similar information. I mean, sometimes a company that's got that turnstile or something working on a production line or something may not exactly want some of that data to get out there.
Exactly.
And there's a couple interesting points that come out of that. One really prime, fertile ground for IoT and that type of thing is obviously agriculture. And there's a good deal of synergy from the data that comes from these things, from the harvesters and that sort of thing. And the data can be sold to Wall Street, basically. And it's also valuable because the farmer, if they're going to get insurance for their crop, they can verify that they did all the correct things to make sure that they were successful. But the idea that maybe they give away some of the secret sauce about exactly how much they're producing, that's a problem, to get back to your turnstiles.
Yeah. Yeah, and I would think even in terms of, staying on the agriculture, how they water, how they fertilize, what they fertilize with. If I'm just a startup or if I'm a competitor, they use that, that different philosophy on how they're watering or whatever it is. So yeah, to get that to Wall Street, that's crossing a lot of gray lines there now.
Yeah, and actually that gets back to one of the challenges, because I come from the semiconductor industry, and we wanted to monitor those testers. In the service organization, we wanted to be predictive. All the things that ServiceNow is trying to put into their tools, be predictive, not reactive.
Yeah.
So we tried to do that, but the idea that the data that was contained on a semiconductor tester, well, it's the test parameters of the whatever the customer's new device coming out. So that was the problem we had to solve, and to some extent we didn't always do it.
But despite that, wasn't there also a cultural challenge to deal with in terms of how the testers approached the task and how that worked as part of the overall intent of the capability?
Yeah, well, that was one challenge that we had to deal with, is that, and this was maybe a DevOps type of situation. We were putting software on the top of a tester that is exactly would be considered maybe slightly the embedded, but to the point where it's instrumentation that are testing their important devices, and you've got to make sure that the software, monitoring software you put on top, or the remote connectivity software you didn't put on top, didn't interfere with anything. So we had to have very strict controls on exactly what we were doing.
So does that, I know I had friends of mine, and I came from the semiconductor space, hardware design, and I remember the lower you get, the less you can introduce to debug, to test, because it actually changes how the effectiveness of the chip. And the system now is being impacted by the testing itself. So how, that's got to be really tricky to do that.
Yeah, I think there's something called the Heisenberg and uncertainty principle or something. I mean, sometimes
you change it.
I think that's probably true. In IT, you try to monitor something, or even you try to monitor users. Or something, and they know that you're doing it.
They're going to behave differently.
Then they're going to, it's difficult. Or if you're trying to test a new app and everyone knows that you're testing it, they're not going to test it in the same way that they're not going to use it in the same way that they would normally.
Hawthorne effect. So we got from the Heisenberg to the Hawthorne effect in one. Yeah, that's true.
But yeah, so what else are you covering in IDC? I mean, you guys cover a broad space. What else are you working in? What sort of coverage areas?
Well, I think the one thing that's very interesting that we're doing is we're looking at the convergence between client virtualization and IT service management. And these areas were traditionally managed quite separately.
Right.
And the idea that organizations are looking to unify this type of management, both devices, whether they're virtualized or not, as customers want their employees to bring their own device, but be able to seamlessly work in between them in ways that make sense. And in which case, you have to unify the processes. And to the extent where you had separate groups in IT servicing these devices and virtualized, the fact that you can unify those makes that go a lot better.
Well, David, thanks for coming on board. I mean, this has been great for me. I mean, it goes back to my old hardware design engineering, so that's always cool. But thanks for coming on. I think it really presented a lot of different topics that we don't normally get. And given some of the discussion this morning of how IoT and how everything's kind of really coming together, you know, this aspect of the manufacturing side of it and those components on the manufacturing line, which if anyone's done any work with manufacturing companies, they know that's the bread and butter. If that production line goes down, that's key. So bringing that into this now is, I don't know, it's looking like it's going to get even more and more interesting. So thank you for coming on, sharing that knowledge with us, and you know, hope to have you on again soon.
All right, I thank
you.
you too, and I think that ServiceNow is doing some exciting things. I was talking to one of your gentlemen on the floor there in that space, so
Thank you.
I'm looking forward to see what's going to happen.
Thank you very much.